Lewin's video screencast number 3. Here's the diagram that I use to help compute all my information. To find the overall height, I just took the formula straight from the long jumper problem and from chapter 4. And I came up with 920 meters, which is 20 meters more than Lewin actually came up with. The overall time, I just converted the time equals distance over rate, and I came up with 26.11 seconds, which is not 30 seconds, which Lewin came up with on his video. And for my horizontal final length, I just took my rate times time, and I came up with 3498 meters. That's a little bit closer to what he came up with, 3,500 meters, but it's still not 3,500 meters. So this is the question that I had. When Lewin approximates his numbers, how can I match his to mine or mine to his? It makes me feel like I am doing something wrong, which I probably am because he's the scientist and I am not. So that's what I came up with for this one. So here's the variables that I used, that I knew as far as the x and y goes. The initial velocity and the horizontal, and then the initial velocity. We had the final distance, and the acceleration I used negative 9.8 meters per second squared. Now if I flip it over, here's the free fall, number 43, part C. Here's the diagram I came up with. In the free fall area, notice how it is only half of the distance of the parabola, so that'll come into play later on when I am finding my time overall. There's my x and y horizontal components and vertical components. So this is what I came up with to get into my quadratic equation to find my time. That 2134 meters is just the difference between the overall 31,000 feet and 24,000 feet. So that's the 2134 converts to roughly 7,000 feet. And there's the quadratic. That's what I used to find my overall time, because that was what the question was asking. Came up with 33.8 seconds. And I just took that 33.8 seconds, divided it by 2, and I came up with a roughly 17 seconds during free fall. And that is video screencast number 3.